Hi guys, so I am on page 81. I'll be showing you how to calculate the center line of curved walls. So example 3.4, you are asked to calculate the center line of the curved wall. Now on your plan you have two known lengths and an arc of unknown length. So to get the center line of your curved wall, you'll have to add this length, the known lengths and your arc. So first things first, you'll have to calculate the length of your arc. To calculate the length of your arc, you have to apply this formula. The formula of calculating the length of an arc, which is theta over 360 times 2 times pi times r. The r, it's your radius. Now, before applying that formula, first thing you have to do is to check your radius. On this plan, you are given the radius. The radius of your arc, it's on the inner face of the wall. So this part, it's your inner face of the wall. Then this one is the outer face of your wall. Now, if you use this radius on this formula, the length that you will get, it's this length, it's the inner length, which is incorrect. So what you'll have to do, you'll have to add your radius with the thickness of your wall. So to get the outer length of the arc, which is correct, you'll then add it with the two known lengths. So let's calculate. So we said we'll apply, to get the length of the arc, you'll have to apply the formula, which is theta over 360. Then it's your times 2 times pi times r. So on your plan you are given theta, or I can say the angle. So your theta is 40 degrees. Then it will be over 360. Then times 2 times pi times r. So like I said, you'll have to add the radius with the thickness of the wall. So you must start with it. That will be 4,000 to 135 plus 220. Okay, let me take my calculator. So 4,235 plus 220 gives you 4,455. So you include this radius on your formula, which will be times 4,455. Now you'll have to get the length of the arc now. So you'll punch in your calculator 40 degrees over 360 times 2 and it's your pi times the radius, which gives you 3,110. You'll include the decimals. You will round it to 2 decimals. So it's going to be 3,110.18. So 3,110.18 is the length of your arc. Now remember, you have to calculate the center line. To calculate the center line, again, I said you have to add the length of your arc plus the two known lengths. So the center line will be 760 plus 3,110.18 plus again 1,240. So if you add those three lengths, they will give you the center line. So 760 plus 3,110.80 plus 1,240. They will give you 5,110.18. So 5,110.18 is your center line. Alright guys, so let's look at another example. So page 82, you exercise 3.6, you are given another curved wall, which is now different from the one we measured before, we calculated before. So here you don't have an arc precise, so you have half of a semicircle. So to calculate this wall again, you can apply this formula. Now, so the center line will be the known length plus the curve. So you're given the radius now. The length which is needed start from this point up until this point, meaning your angle will be 90 degrees. Again, first check your radius. So your radius is on the inner face. What you have to do first, you have to add the radius with the thickness of your wall. So you'll go to your paper. So on the plan, you had the radius which was 3860. There you'll add plus 2 of, you'll add 220. You'll add 220. So the radius will be at the outer face of the wall. So that answer will be 4080. Which is the radius. Now after you have the correct radius, you'll have to put your formula. So you'll apply your formula. The formula will be 90 degrees. Like I said, the angle will be 90 degrees because we're looking for this length starting at this point up until this point. So that angle is 90 degrees. If you can check it with your protractor, it's 90 degrees. So it will be 90 over 360. Then times 2 times your pi times the radius you got, which is 4008. Then the answer you'll get here, you'll have to add it with the known length, which is 2300. So when you add the length of your curve plus the known length, they will give you the center line. Now again, you have another plan. So again, to calculate the center line of this curved wall, you'll have to add these known lengths and the length of your curves. So again, you have to check your radius. So your radius, it's on the inner face of the wall. You'll have to add the thickness. Also with this one, it's on the inner face, you'll have to add the thickness. So first, let's calculate the radius. So it's 1840 plus your 220. Then again it will be 1120 plus 220. So it should be the answer here will be 2060. Then the radius here will be 1340. Okay, now if you see here, it's a semicircle. Also here it's a semicircle. So to calculate, first to calculate the length of the curve, or I can say the semicircular curve, you can apply the same formula, which is theta over 360 times 2 times pi times your radius. Now your theta will be 180 degrees because we want this length starting at this point up until this point. So if you place your protractor here, that angle it's 180 degrees. It's a straight line, so it's 180 degrees. So you can go and substitute 180 degrees over 360 times 2 times pi times your radius. Your radius was 2060. Then the length of your semicircular curve will be, let me punch it in on the calculator. So the length will be that length would be 6,471.68. And again, you'll have to calculate the length of this semicircular curve. So it will be, now your angle again here, it's 180 degrees, so it's gonna be 180 degrees over 360 times 2 times pi times your radius. So got that the radius was 1340. So again, you calculate that length, which is 4209.73. Then, since you now have the length of your two semi-circular curves, you can then calculate the center line. The center line, which will be the 1200 plus the length of your semi-circular curve, which is 6471.68 plus another length of your semi-circular curve, which is 4209.73, then plus 850, which will give you the center line. So if you add these four lengths, they will give you the center line. Now you could have done it in another method. You could have used the formula to calculate circumference of a circle, which is 2 times pi times r. So 2 times pi times r is the formula to calculate circumference length of a circle. So what you could have done here, first you'll have to get the accurate radius, which is the outer face radius. So you'll say 2 times your pi times the radius of this semicircle. We got that it was 2060. So we'll say times 2060. So you'll punch it in your calculator. Which gives you this answer, 4120 pi, which you will divide it by 2, because the 4120 pi is the length, it's the circumference of a circle, whilst we want the length of the semicircle. So you'll divide that answer by 2. Then you'll book it in. You'll write the answer in decimals. So it's going to be 6,471.68. Then again, you'll have to calculate the length of this semicircle using this formula. So it should be 2 times pi times the radius, the accurate radius. So we calculated it before, which was 1,340. So we'll put the 1,340. So again, you'll have to divide the answer you get here by 2 to get the length of this semicircle. So it will be should be 2 times pi times 1,340. Answer, you'll divide it by 2. Then you book the answer. You have to book the answer in decimal, which is 4,209.73. Then after that, you'll have to add the 2 lengths of the semicircular curves plus the 2 known lengths to give you the center line of the curved wall. So if you can also look closely, you get the same length the same length. Same length for the semicircular curves when using both formulas.